Imagine launching a nuclear power plant into space. Not a battery, not a small generator, but a real nuclear reactor. Could a space shuttle actually carry something that powerful into orbit? And more importantly, should we even try? Space missions require enormous amounts of energy. The International Space Station uses solar panels, but sunlight becomes weaker the farther we travel from Earth. If humanity wants to build large space stations, travel to Mars, or explore the outer planets, solar power might not be enough. That's where scientists begin considering something much more powerful: nuclear fission reactors. Nuclear fission works by splitting atoms like uranium, releasing huge amounts of energy. A reactor the size of a small car could produce continuous electricity for years. Unlike solar panels, it would work in darkness, on distant planets, or deep in space. This makes nuclear reactors one of the most promising power sources for future space stations and long missions. But getting a reactor into orbit, it's a completely different challenge. NASA's Space Shuttle was designed to carry large payloads into orbit. In theory, it could launch heavy equipment weighing up to 27,000 kilograms. So technically, compact nuclear reactor could fit inside the shuttle's cargo bay. But there's a major problem: launch safety. If a rocket carrying nuclear fuel failed during launch, radioactive material could spread across Earth. Because of that risk, every nuclear launch would require extreme safety systems and international approval. In fact, nuclear power in space isn't just a theory. NASA and the US government have already used radioisotope generators to power spacecraft like Voyager and the Mars rovers. And today, scientists are developing projects like NASA's Kilopower reactor, designed to power future missions to the Moon and Mars. These systems are smaller than a full power plant, but they prove that nuclear energy can work safely in space. One day, future space stations or deep space missions might rely on compact nuclear reactors instead of solar panels. If that happens, rockets or something like the Space Shuttle may need to launch them into orbit. The idea sounds dangerous, but it might also be the key to powering humanity's next giant leap into space. Because in the darkness of deep space, energy means survival. Subscribe to Nexafacts for more mysteries and science behind the future of space exploration.